Okay, this lesson is for Mrs. Cucci's College Now Pre-Calculus class. We're on lesson 7.3, which is complex numbers, trig notation. And this is Mr. Zulum again. Okay, so today we're going to be looking at complex numbers. Now remember, complex numbers are the form a plus bi, where I is the square root of negative radical 1, or of radical negative 1, imaginary number, and a is just the real number. Put them together to get the complex number. And what we're going to be doing is graphing them on a graph. Except instead of having like a regular graph where we have x and y, this is going to be called the real axis. This is the imaginary axis. So to graph, for instance, let's say 3 plus 2i, we would go over 3 units on the real axis and then up 2 units on the imaginary axis, and that's 3.2i. 3 plus 5. If we had another one, let's say, such as negative 4 minus 5i. Negatives work just the same. We're going to have to go to the left 4 on the real axis and down 5, 2, 3, 4, 5, down 5 on the imaginary axis, and this is negative 4 minus 5i. And of course, if we were given something with just, let's say, negative 3i, this means our a is 0, so we're not going to move any distance on the real axis, but we're going to go down 3 on our imaginary axis. And if we had something like just 2, that is 2 on the real, 0 on the imaginary. So what we're going to look at, now that we can graph it, is we could find the distance of a point. And the way we're going to find the distance is we're going to remember that the absolute value of a complex number, so the absolute value of a plus bi equals the square root of a minus 0 squared plus b minus 0 squared. And the way we're getting this is we're thinking, remember, we have a graph. I'm just going to abbreviate this as real and imaginary. Okay? Say we have a point somewhere out here that's point a plus bi. And what we're concerned about is finding the distance from the origin to the point. So this is just our distance formula that we remember from geometry. I believe you learned it in sum of the squares. A minus 0, and this is going to be a height b on the imaginary axis, minus 0. Both of them squared, and of course if we simplify this a little bit, we get radical a squared plus b squared. So this right here, so this means that the absolute value of a plus bi equals radical a squared plus b squared. So by knowing that, we can find some values. Let's try an example. Say we wanted to find the absolute value of 3 plus 4i. We know this is equal to the square root of 3 squared plus 4 squared and that's going to come out to 5. We'll try another one. Say negative 2 minus I. We have negative 2 squared plus, remember there's an imaginary negative 1 in front of there. Negative 1 squared. And that equals radical 5. You can't simplify that any further. Remember, when you're doing these, to watch your parentheses carefully. The whole negative 2 is being squared, not just the 2. Okay, so now that we know that, let's go a little bit deeper into this. I'm going to talk about the actual trigonometric notation now. So imagine, once again, I have this graph, and I have this point over here, and I call this point A plus BI. Remember, this is my real axis. This is my imaginary axis. Now I could call this point A plus BI. I could also write it in standard coordinate plane notation. You just have to remember that in this coordinate plane, this does not mean X and Y. This means real, imaginary. And so now let's think. This distance right here, I'm going to call this distance R. And remember, that distance R is what we just found up there using the absolute value formula. And if I drop this down, here's my distance on the real axis. That's my distance A. And this is my distance B. Distance of my imaginary axis. And of course, that's a right angle. So we have a right triangle, and we can use trig. Notice that the cosine of this angle theta equals A over R. Or A cosine theta equals R. And by the same token, sine of theta equals B over R. Which means that, not B sine theta. Be careful when you're doing your cross multiplying. Be careful when you're doing your cross multiply. This is actually R cosine theta equals A, and R sine theta equals B. Sorry about that. So this means that if we plug this back into our A plus BI notation, instead of writing A plus BI, we can write R cos theta plus R sine theta times I. And if we do a little bit of factoring, GCF, we have R times cosine theta plus I sine theta. This right here is our trigonometric notation. This is also called polar coordinates. So let's take a look at some examples. Now that we know that formula, let's say they give us 1 plus I, and so this is standard notation, they call it. A plus BI is standard notation. And they want us to write it in terms of trigonometric notation. So the first thing we see is that A equals 1 and b also equals 1. Remember, it's b times I, so our b is 1. So we know that r is radical a squared plus b squared. So r equals a squared plus b squared, radical a squared plus b squared. So if we plug in 1 squared plus 1 squared, r equals radical 2. So now if we go to our formula, other formula, now that we have r, we can write this in terms of sine and cosine. We can say this is radical 2 times the cosine of some angle theta plus I times the sine of some angle theta. What are those angles? Now we have to go back to our definitions of sine and cosine. Sine is b over r, which is 1 over radical 2. I'm going to rationalize and get radical 2 over 2. Now I do my sine inverse. And this one you should have memorized. You should know that it's pi over 4. And remember, we might have an ambiguous, we might think we might have an ambiguous case where it's also going to be 3 pi over 4, which is in quadrant 2. However, think about our graph. We have 1 plus I, up 1 and over 1. The point is right here. The point we know is in quadrant 1 if we graphed it. So ignore that. Our answer is pi over 4. Which is, of course, 45 degrees. So same thing for cosine. Cosine theta equals a over r. A is also 1 over radical 2. And I'm just going to jump right down to it. That cosine inverse radical 2 over 2. Remember, this is radical 2 over 2 when we rationalize. That's also a 45-degree angle. And once again, we know it's in quadrant 1, so we know that's our only angle. Plug these into the formula as well. Close to 45. Plus I sine of 45. And there we go. Okay, so let's do another example. Let's say we are given radical 3 minus I, and we want to convert this to polar. So the first thing I would suggest thinking about is the graph, and here we're going to go radical 3 on the real and down 1 on the imaginary. So we're going to be somewhere in the 4th quadrant. I don't care about exactly where, I just know I'm in the 4th quadrant. And that's going to help me get my signs right on my trig values when I get there. So A is radical 3, and B is negative 1. Knowing this, we can find our R value, which is our A squared, radical A squared plus B squared, so radical 3 squared plus negative 1 squared. R equals 2. I'll plug it into the calculator. Knowing that, we can just go ahead and find all our stuff right now. Sine theta, we know is A over R, or B over R. Sine theta is B over R. Be careful with that. Which is negative 1 over 2. So sine theta equals a half. Cos theta is A over R, which is radical 3 over 2. Positive. Now remember, we're in quadrant 4. So when we do our trig inverses, we have the sine inverse of negative half. We only care about the quadrant 4 angle, and that is 11 pi over 6 in radians, or 330 degrees. And for our cos inverse, remember, this works out nice. We're in quadrant 4, so cosine is positive and our sine is negative. That works out nice. And we note that this is also 11 pi over 6, 330 degrees. So this means our final answer for our polar coordinate is going to be that radical 3 minus I equals, in polar, we have our R, which is 2, times the cosine of 330 degrees, plus I times the sine. (330 degrees). Okay. To go the other way, take a look at this example where we have 2 times the cosine of 120 degrees plus I times the sine of 120 degrees. We want to write this in standard A plus BI form. So notice, we know what our R is. We know our R equals 2. And then we also have to remember here, our original formula, cos theta equals A over R. Cos theta, we know this. We know cos theta is 120 degrees. We know our R, I'm going to bring this over to this side, is 2. We know that equals A. I did that cross multiplication. So 2 times the cosine of 120 degrees is 2 times a negative half. Remember to watch your signs very carefully in this. So negative 1 equals A. We use the same line of thinking, remembering that sine is B over R. Bring this over here, we have 2 times the sine of 120 degrees equals B. And that's going to come out to 2 times radical 3 over 2, which is radical 3. So this means our final answer, remember, we're looking for A plus BI form. Negative 1 plus radical 3I. Don't forget to put that I in there. Okay, that's all the time we have for today. Remember to bring any questions to class, and we'll see you next time.